In the previous question, we were asked to find the mean and variance of an exponential random variable using the moment generating function, and they specified the parameter of the exponential distribution as theta. In this question, they didn't specify the parameter of the exponential distribution, so we can use the default parameter, which is beta. Now, in this case, we need to use the characteristic function to find the mean and variance, and the characteristic function of an exponential distribution is given by 1 minus I beta t to the exponent of -1. And to find the kth moment of any random variable using the characteristic function, we use this equation. So now, to find the mean, so with this equation, what it means, if you want the first moment, the k is for the first moment. So if you want the first moment, you use I raised to the it's negative I raised to 1, and then you use the first derivative of the characteristic function at t equals to 0. Sorry for that, that was a mistake. And then if you are looking for the second moment, which is ey squared, you substitute 2 here. It's I raised to the exponent of 2, and then the second derivative of your characteristic function evaluated at t equals to 0. And then we also use the rule that I squared is equals to -1 when we're dealing with characteristic functions. So now we need to find the first derivative of our characteristic function, which is now -1 into 1 minus I beta t times, raised to the -2, because we have to raise the exponent by 1, multiplied by the derivative of the inside. We are still using the chain rule, which is negative I beta. Now this is negative, it's not negative because the negatives cancel. I beta into 1 minus I beta t raised into the exponent of -2. This is the characteristic function, the derivative of the first derivative of the characteristic function at t. Now the first derivative of the characteristic function at t evaluated at 0, we have I b to 1 minus I beta 0 -2. We know that this will be equals to 1 because this will evaluate to 0. 1 minus 0 is 1, and then 1 raised to any exponent is 1. So this will be equals to I beta. Now ey, which is the mean, now we use this equation, negative I raised to the exponent of 1 multiplied by the first derivative of our characteristic function evaluated at 0. We have this multiplied by I beta. So now I raised to the exponent of 1 is I, so negative I multiplied by I will be negative I squared multiplied by beta, and I squared is equals to -1, so -1 multiplied by beta is equals to beta. So our mean is equals to beta. Then now our variance is still equals to the second moment minus the first moment squared. So now we need the second derivative of our moment generating function to find the second moment. So we'll derive the first derivative, which is I beta into 1 minus beta t raised to the exponent of -2 with respect to t. this will be equals to negative 2 I beta into 1 minus beta t raised to the exponent of negative 3 multiplied by, no, there's an I there, the derivative of the inside, I forgot the I, sorry, derivative of the inside, it's negative I beta. So now this cancels with that, we have I squared 2I squared beta squared into 1 minus I beta t raised to the negative 3. And then I squared is equals to negative 1. And this will be equals to just 1. So we have negative 2 beta squared into 1 minus 0 raised to the exponent of 3. This is equals to negative 2 beta squared. When we are evaluating the second derivative of our characteristic function at t equals to 0. Now, our second moment, ay squared, is equals to our negative I squared multiplied by this second derivative at t evaluated at 0. So now this will be I squared multiplied by negative 2 beta squared, and we know that I squared is equals to negative 1. Negative 1 times negative 2 beta squared is equals to 2 beta squared. Now the variance of y will be equals to 2 beta squared minus beta all squared, which is then now equals to 2 beta squared minus beta squared, which is equals to beta squared, which is the same variance and the same mean we found in the previous question, but in this case we're using the characteristic function, and also the parameters have changed from beta to theta. In the previous question we found that the mean was theta, and in this one it's beta. Previous question we found that the variance is theta squared, and in this one we have beta squared. Thank you.